It has come to my attention that there exist people who walk this earth unbothered when the hyperlink contains a trailing or leading space. They look at this and think, that's fine. You see the problem though. Enhance that. Yeah. That's Adobe Illustrator, which costs $600 a year. Now, I am not like that. I'm a detail guy. Like, if you work with me and you send me a PowerPoint presentation, I'm going to spend most of my time making sure that the bullets are the same color and size. How do you even do it? It's like the people that made the software don't even care. I'm bothered by details everywhere I go. If a character in a TV show is handling a coffee cup, but I can tell from its moment of inertia that the cup does not contain any liquid, I completely lose suspension of disbelief. If I'm staying in a hotel, I need to turn off auto motion smoothing on the hotel television, even if I don't plan to watch TV. And then by a miracle of physics, while filling up this one water bottle, I've somehow saved more than one plastic water bottle. Now, I don't care how as your H2C is, that's a logical impossibility. I can barely bear to play the word game Wordle, whose expert mode rules are simply wrong. It says right in there, any revealed hints must be used in subsequent guesses. And if you think about it, they just did this wrong. It's just wrong. It would be easier to implement it the right way, but it's buggy. One time, and this is not an exaggeration, someone sent me a presentation to edit, and I found myself spell correcting their lorem ipsum text. It had said lorem ipsum, which is funny. I think about that incident a lot. But the person that wrote that probably doesn't. He probably hasn't even read the Wikipedia article on lorem ipsum. This is our villain. I'll call him lorem ipsum. He's the kind of guy that mostly cares about it looking good and sounding right, not being good and being right. For example, if you tell him there's a mistake in the math, he takes this as some kind of personal attack. And there are some phrases he loves, but he doesn't really understand why. On the other hand, he is successful and rich. The opposite of this person is the hero called Donald Knuth. Now, if you watch this channel, there's a good chance you admire Donald Knuth, as I do, and you probably know his story. But one of the things that I find most inspirational about Donald Knuth is that it took him 49 years to write a single book, and he's still at it. To be fair, it's become more than one book. But he started in 1975. He wanted to write down all of computer science, which probably sounded a bit ambitious at the time too, and now it is just absurd. But his first attempt was 3,000 pages of handwritten text, which he brought to the publisher, and they were like, I think this is probably going to be more than one book, Don. So he said, okay, fine. Let's just start with one, which became two. And a couple years later, those are close to being ready for publication, and he gets the proofs back from the publisher, and they just don't look that good. Like the typesetting isn't beautiful. Now, I can certainly relate to Donald Knuth on that one. This is my dissertation, which I wrote many years ago. And it's a lovely document. It's filled with hundreds of pages of proofs and mathematical diagrams, and I am proud of it. But when I got it back from the printer after graduating, I found that the title was misprinted. This is the only part I didn't do, which is the gold embossed title on this document. And it's supposed to say modal types for mobile code, and it says model types. So that's nice. So Knuth puts the book on hold, and he writes his own new typesetting software, which is called Tech. This takes quite some time. And it wasn't just like he was programming his own version of Microsoft Word. He was inventing new ways of doing typesetting and new text layout algorithms. And as he did this, he needed to invent all sorts of new stuff and kept going down. Every time he found a rabbit hole, he would go into that rabbit hole where there would be more, and he would go into those. I really like to fantasize about the conversations he probably had with his editor. Like, hey, Donald, I hope you're well. Just wondering if you have an update on when 4C will be ready or any more chapters. I am working diligently on chapters for Volume 4C. As I've mentioned in the past, it's impossible to tell how long it will be, since mathematics does not obey the rules of project management. I just need a date to tell the publishers. Like I've said, any date would be very low confidence, other than the fact that it will be in the future. I just need a date. Would you like me to say a date, knowing that it's a very low confidence guess and that I would be extremely likely to miss that date or even deliver early? Early? Now we're talking. What use is the date if you're excited about the possibility of it being early relative to some unknown date? I just need a date for the publishers. 2030. Thanks, Donald. You're the best. Volume 5 is estimated to be ready in 2030, when Donald Knuth will be 92. Now, Tech is not just used for Knuth's books. It's widely used in academic document preparation, especially computer science and mathematics. I used it to typeset my thesis, for example. Except for the cover. So a significant fraction of all human knowledge is encoded in these documents that were prepared using Knuth software. And that text was slurped up by this guy, the LLM. Now I suspect you're tired of hearing about these things too. Personally, I find this stuff to be simultaneously distressing and fascinating. I think it's fair to say that the LLM is a lot more like Lorem Ipsum today than it is like Donald Knuth. It's good at generating text that sounds good and seems right, and not so good at generating new thoughts that are mathematically precise like Knuth is. But it's got a tiny toehold of precision in it, and that does distress me. Now, I don't suppose that this is controversial, but here is a humorous antidote to illustrate. I was presenting an earlier version of this project at an event where some YouTube legends were also presenting. And as is my way, I wanted to troll them. So this thing where I go on and on about different mistakes and how they irritate me, I thought I could find some mistakes made by these YouTubers. One of these people is Grant Sanderson of 3 Blue 1 Brown, great channel. And I was like, I don't know, has he made any mistakes? So I asked the LLM, Google Bard, sometimes it's good at this kind of thing. Did 3 Blue 1 Brown ever make any famous mistakes? And it says, well, Grant is like very transparent and he's very thoughtful. But he did one time make a dedicated video explaining all his mistakes and correcting them. And I'm like, that's perfect. So I click on this link, which is a real video called Error Correction is Incredible, a presumably flawless video explaining the mathematical technique of error correction. So that backfired. Score 1 Grant. Anyway, I don't think there's any avoiding the LLMs or their successors. We're going to have to learn to live with these things. Now, when something's stressing me out, especially something technical, I find it to be very therapeutic to do a programming project with that thing. So I was looking for some inspiration, and I was just thinking about words that are shared in common between the things that I like. For example, typography and functional programming both have a notion of type. Functional programming and machine learning both have a notion of ML, or tensors. And since machine learning has claimed a great many words, there's also a number shared with typography as well. And I thought, okay, well, here's a good project. Maybe I could at least get something that I want, like perfect typography. So now I'm almost ready to tell you what this video is about. But first, we need to talk about Super Metroid. Metroid is a video game series about a brain that's been placed in a vat and enslaved by the capitalists called Space Marines. Its goal is to increase the score as high as possible by conquering the galaxy. In the 1990s, a website called GameFAQs collected together text documents that were guides about how to beat games, or to beat them really quickly. And another one of our heroes, this person called RS1N, was developing a speedrun guide for Super Metroid. And they noticed that a few lines in a row lined up perfectly, and they thought that this was really satisfying. So they did what you would normally do, which is write the entire 30-page guide this way, just carefully choosing words so that all of the lines would line up exactly right and without cheating. There were no extra spaces or stuff like that. This is quite a work of art, but it is also very tedious. On the other hand, I do like to automate the tedious chores of speedrunners. And in fact, the LLM is quite well suited to doing this. And you can definitely find a lot of explainers for LLMs on the internet, so I'm not going to try to do a complete job here, but just one slide on the basics. So it's just a machine learning problem, which means that you train it on some input-output pairs, and you develop a model that can predict the output from the input. And you use fairly standard techniques to do this. So in this case, we trained it on like the whole internet, and the model is just enormous. I mean, it's like 70 billion parameters, the one I'm using. But fundamentally, it takes a sequence of words and then predicts the next word. And actually, it's not just predicting the word, and I know they're tokens. It gives you a probability distribution over all of the possible next words that follow this sequence. So for example, let's say that the sequence, the input, is something like, this is the most beautiful, and we're asking it to fill in the blank. And rather than give us one word, it actually gives us the probability for each next word. I made these up, sunrise, maybe. So now what we can do is pick one of those words using the probability distribution or not. For example, we could roll the die and somehow we choose the word typesetting. Then that goes in the sequence of words and we run the whole thing again to produce the next word. Same thing. And by sampling from this distribution, you can generate text. Now you can use this to make chat, but it's not just chat. It's a general purpose sequence prediction machine. So when Lorem Ipsum gets all excited like, ooh, it's Gen AI, what he really means, or what he really is referring to, is the fact that it's generative. But this is something we've always been able to do. This is not like even close to being the interesting thing about this. The interesting thing is that those probability distributions are surprisingly accurate. And this is not to be confused with genitive, sometimes called the possessive case. I know about the grocer's apostrophe, so I can kind of forgive that. But look more closely here. What is the difference between milkshakes and hoagies that would require an apostrophe in one of them but not the other? They're clearly just trolling me. Is that supposed to be a chicken? Because it actually looks like a trash bag. Okay, so back to the project. We're going to provide the model with some text sequence, and it's going to predict additional words. And that sequence consists of a few parts. The first part is instructions. The instructions are like, here comes a paragraph, and then another copy of that paragraph that might be like slightly different. I'm not going to tell the model to try to make the lines line up. That's actually really hard for it because it doesn't really see how words are spelled. I'm just conditioning it to expect two paragraphs that are similar. Then I put the original paragraph in there, the one that I want to make all line up. And I say, here comes the rephrased one, and that's the input. Now it can generate words that follow that, but it wants to generate like another copy of that same paragraph. So let's say that this is the original paragraph that I inserted in there. Doesn't matter. So now what's going to happen is that we're going to generate words according to the probability distribution. But this blue is the target size. And if I go over the blue, if it's too long, I'm going to travel back in time and I'm going to try again. You can also see the actual probability distribution on tokens down here. So I thought the most likely word is here, but it chose this. And we generate words that way. That one was also too long. Too long. Too long. Aha, perfect. So whenever I land perfectly on the right length that I want, I save that and I go on to the next line, continuing that text. And it goes and goes and goes and produces pretty decent results. The LLM is actually quite well suited to this problem, finding variations of text that keep approximately the same meaning. In this particular example, it was trying to fill every line completely. So I like that it made these little sunglass emoticons. So I did it, and it works pretty well, but it has some downsides. For example, it was only 300 lines of code, and it took only an afternoon. And you have to look at monospaced text, which is okay, but I would like to do this with like real fonts. Now, if I were a wiser person, I would have just stopped there, but I am not a wiser person. I am a computer science idiot. And so here is my Knuth any % speedrun. I took this core idea and fleshed it out in a new document preparation system like Tech. It's called Bovex. It features a full-featured typed programming language with kerning and hyphenation and all that crap. I did make some new fonts and new software for making fonts, although I did not go as far as Knuth. Of course, it has this AI-enhanced text layout algorithm, and then I used Bovex to write a paper about Bovex for SIG Bovic this year. This talk is not about the papers, but I did also use Bovex to make these slides. For example, here's what this slide looks like. This slide is actually just an image of the source code of this slide, but you can see that there's like a real programming language here. And I want you to know that I really did not cut corners on this programming language. My specialization in grad school was about typed programming language implementation and compiler design and other things like that. And so you might think that's an advantage, but honestly, it just means that when you're doing it, you can't bear to do it any way other than the best way. So spend really long time on that. Here's the source code of the whole thing, which this didn't fit in HD, so I had to upgrade. All my videos will be in 4K from now on so that I can fit the source code on them. And here's the part of the source code that makes this slide. At the core of Bovex's typesetting algorithm is this thing called boxes and glue. And it's an algorithm due to Knuth. He called it, I think, algorithm 4. And Knuth is good enough that he doesn't even have to give things good names for them to be very successful. And what the boxes and glue algorithm does is it takes boxes, which are items of fixed width, let's say words or pieces of words, and glue, which is like little springs that go between the word pieces. Glue is where the action is. It has an ideal size that it wants to be, but it's willing to compress or stretch, except it has some cost associated with that, which we call badness. It's also possible to break at some glue, like a line break, and that has an associated badness as well. So the way that you use this algorithm is to take your text and turn it into boxes and glue as appropriate. And Knuth's algorithm can find the very best way to break the lines, like where should you press return, basically, in order to minimize the overall badness. So obviously the glue is used for spaces, but we also use it for stuff like kerning. We use it for hyphenation. Even though it's not great to have a hyphen, it's often better than a large space or compressing too much. So it's a good option to have on the table. And if you don't like hyphens, you can turn up the badness of hyphens. This algorithm is a lovely, almost canonical example of dynamic programming, and I'd love to go through it, but this video will be too long anyway without that. Here's a visualization of the table it builds. Basically, it tries all of the combinations, but in an efficient way. It doesn't redo any work. And this zigzag line essentially represents the most efficient, that is, lowest badness path through the table that it generates. But the important thing to know here is that doing this greedily produces much worse results than if you actually do a global optimization like Knuth does. So boxes and glue is really good. Bovex uses this, but Bovex enhances this with the possibility of changing the words. So remember that the LLM gives us a probability distribution on next tokens. So there isn't just one sequence of boxes and glue, but after every word or word part, there's more than one option for what to generate next. And moreover, there's a cost for what those options are, which is how likely they are, right? So the most likely word, in fact, if you pick the most likely word, you're just going to get the same as the input paragraph. Because after all, you've told it, hey, here's a paragraph, and then there's another copy of the paragraph underneath it. The most likely second paragraph is the same as the first paragraph. But minor variations in word choice or punctuation will also have high probability. So Bovex's algorithm finds the best way of rephrasing the text that maximizes the probability and minimizes the badness using Knuth's algorithm to produce the best line breaks. Now, I wish I could tell you I found a really elegant way of interleaving these two things, but it's tricky enough to just get it working. For one thing, the text can contain markup in it, like there can be inline images or math. And the LLM wants to work with text, so it's not a great match. Also, the LLM is so slow that just dominates the runtime, so it's all about generating the fewest tokens. But it does work, and as a result, I can get something like this. So both of these columns are dynamically changing to show you how the text appears at different widths. And the left is Donald Knuth's algorithm. So the text stays exactly the same, and all we can do is choose hyphens and line breaks. It's not bad. On the right, I allow rewriting the text a little bit in order to make it fit better. And I think it does look better. Now, of course, it might not be right. Like it might change yes into no, or the math might not be right. But like I said, that's coming anyway. So we might as well have text that looks good. And in any case, Bovex gives us a controlled trade-off between these two states. By changing how much it costs for the text to be semantically wrong, we have a dial that allows us to smoothly interpolate between Lorem Ipsum and Donald Knuth. And actually, when I told you before that I used Bovex to write a paper about Bovex, there are actually two papers. One, Knuth's version, is the original text, which is just laid out as written. The other, Epsum's version, has been maximally rewritten in order to make the lines line up as best as they can. Now, if you like suffering undocumented programming languages with inscrutable error messages, you can download Bovex from my website, or study its unhinged source code. It's open source, available at your option under the terms of the GNU General Public License, or the GNU Justified General Public License, where all the lines line up. Due to rabbit holes, Bovex also includes a number of other features, for example, 3D text, and it has an achievement system. Because another thing I don't like is when software won't acknowledge that you've reached an obscure error state, essentially outsmarting it. So with Bovex, you can unlock an achievement for producing a document with nan badness. Of course, it has a chess engine because I needed some code that was actually slow so that I could spend time writing optimizations. And wouldn't it be nice if you received a paper and you could just play chess with that paper against a strong AI? Of course it would be nice. Or maybe in the future it could automatically rewrite itself in order to respond to reviewer comments and show a kind of humiliating deference to their ideas and insert references to superficially related work and so on, so that there doesn't need to be this back and forth. Maybe this could reduce publication delay to the order of a year, maybe even months. And rather than just limit it to rewriting text, you could also give it access to commands on your operating system, like so many other irresponsible researchers. For example, here's a challenging to typeset paragraph. It has several long tokens in a row, especially this number 1 billion. Now, we could make it look better by just changing the number, but that would increase the semantic drift. It's possible, however, to have both. What if the LLM can simply make more paperclips exist? Then we can have beautiful layout that is still completely accurate. Now that's what I call AI alignment. But for now, I'm really satisfied that I found the missing part of this Triforce, and we can call it a day. In this talk, and with this talk, I presented to you Bovex, a new computer typesetting system. It follows in the tradition of Knuth's tech, but with modern amenities such as requiring over 128 gigabytes of RAM. And finally, I can be spared all of my typographic irritants. But not all of my irritants are typographic. For example, I really don't like when they're swabbing your nose and they just stick the thing like all of the way up there, way into your brain. Like, my brain is private. Leave that thing alone. What do we have here? Some kind of crime scene? Oh, looks like you left a note or a research paper or something. This looks nice. Good typesetting. AI, huh? Normally I would say that that's just an unnecessary perversion. But looks like this use of LLMs was fully justified. Oh, another thing I don't like is it's like screen space reflections. Like when you're playing a video game and the surface of the water is just like a copy of the screen upside down. That's just not how lakes work. Why are you telling me this? Let's get back to the case. Now, what I don't get, Tom, is why did you do it? I understand killing someone over an apostrophe. I put the apostrophe's killer behind bars after all. But an en dash? That's basically the same thing as a hyphen. Have you ever played Wordle? Tell me what I want to know. Look, you little turd. What did you do with the computers? That's not realistic.